Our topic is secure communication channel for IoT devices. So in this topic, we have chosen the domain of electricity meters. In the current existing system, meter readings are taken manually, in which a person comes to our place and takes the readings. In our system, what we have done is that automated the previous system in order to automate the readings and get them get them automatically. So the main objective of a system is to ensure security between IoT devices. And for this, we have used Raspberry Pi 3B Plus. We have used AES 256 algorithm for secure transmission. This system prevents multiple cybersecurity attacks and helps to get the meter readings in terms of in the times of pandemic automatically. So this is our literature review. We have used ECC elliptical curve cryptography, and we have used this paper as a reference for applying ECC in our project. We have used another paper and enhanced AES algorithm using cascading methods, but we have used it on 256 bits key size. We have used William Sterling's book for reference for explanation of algorithms AES, HMAC, SHA, and CBC.
Getting to the objective,
Steve.
our main motive in the project is to create a secure communication channel, as Aditya mentioned. We are also focusing on various other aspects, that is authentication of the customers. For this, we are storing the user's password in not in plain text, but we are using a password key derivation function, which creates a SHA value of his password and iterates it 50,000 times. We are also making use of the AES 256 algorithm to encrypt data which is sent over the network. We also use the ECC elliptic curve key pair, which also helps us to maintain the integrity of the data when sent between two systems. Our application prevents multiple cybersecurity attacks such as man in the middle, DDoS, SQL injections, eavesdropping, and user impersonation. Over to Santosh.
Okay, this is our problem statement to implement a secure channel for data transfer using asymmetric and symmetric encryption algorithms for IoT-enabled smart devices. Okay, the first thing that comes into existence is our main system. Along with comes the database, and then other entities come into existence. Then after the main server, IoT server comes into existence, and then IoT devices come into existence. They register themselves with the main server, and this takes place by the exchange of keys. We are using ECDH here and not the normal Diffie-Hellman key exchange. With the ECDH, AES 256-bit keys will be exchanged, and this is very much like ECIES. And after that, whatever the information exchange takes place in that, for checking the integrity of the data, we are using SHA-256, and for checking the authentication, we are using ECDSA. Next, after all the IoT server, IoT device, and main server get established, then the customer comes into existence and he registers himself with the system, and then he is assigned a IoT server and IoT device, and after that he communicates securely with the main server. Now, whenever the meter readings are to be fetched, a session key is generated using ECIES mechanism, and of course our symmetric key is AES 256-bit key. And whenever the customer feels like he has some query regarding the bill issue, then he can contact the admin. He can raise a security ticket for that.
Our project is divided into 3 modules, namely the customer part, the server, the main server, and the Raspberry Pi, which is also the IoT device, or the meter. The customer part, we have used ECDH and AES as the algorithms. ECDH is used for, we've used ECDH to exchange the key, which will be used for our AES encryption. Now, AES has 13 rounds and one final round. The 13 rounds, as you can see, are key expansion, add round keys, and 13 rounds of operation where the data is encrypted, and then we have one final round. For the next module, that is the customer again, the here we are, for our project, as Santosh had mentioned, we have uh, implemented a system where the customer is able to raise a query with the admin, which is on the main server side. So for that also, the we have implemented AES-256 for encrypting the message, or rather the complaint that the customer can raise with the admin. The next module, which is the main server, here we have used ECDH again for exchanging keys between the IoT server or the customer or the IoT device, which will be used for further communication. And for encrypting the data, again, we have carried forward with the same algorithm, that is AES-256. And as I've explained before, the process is the same. Now, the next module is Raspberry Pi, and although it has the main data, that is the meter readings, which is extremely important, and therefore we have to encrypt this data on the device, rather the IoT device, before sending it to the IoT server. So for that, we've used AES-256 again for encryption of the data. And we've also made sure that the message is authenticated, that the end user knows that this message is not tampered with. We have used ECDSA, which creates the signature of the message. Here we've used ECDSA with SHA-256, so it creates a hash value of the signature on both the server side also, where it's authenticated, and the device side also, where it's authenticated and sent. The features of the features we've used are AES-256, which is, as I've mentioned, we've used it for encrypting the data which is being sent between the device and the server, or the user and the server. And we've used ECDH, which is used for transferring the keys, which will in turn be used for AES encryption. ECDSA is used for providing authentication to make sure that the data is not tampered with, and SHA-256 was just used for creating a hash of the signature that we were creating using ECDSA. Now moving on to Santosh.
Okay, here's our use case diagram. Firstly, what will happen is system administrator will be present, and he will have many tasks like IoT server registration, then IoT device registration. After that, the customer will come into existence, and his first task will be registration. After that, he may generate a query ticket after the admin generates a monthly bill, or he can also see his previous bills, or fetch his previous meter reading bills, or his current bill, or he can also manage his account. And with the edit profile, we are given options like update his own email address, update his password, and update mobile number. It is our DB diagram, and basically we have many tables here, including the property one, where the property, we have kept a concept of tenant and owner, where if you are the owner, you will have to register your property at first, and then you will send the registration link to whoever resides at your place, the tenant. And then there is user table. We have stored various entries at here. Then
Just to add to what Santosh just mentioned, all our tables have been normalized. Like data is in a normal form in all our tables. And taking this forward, I would hand it over to Aditya to explain the system specifications.
So these are our system specifications. In order to ensure security, we require softwares which are updated. So we need Google Chrome 69 and above, Internet Explorer 11 and above, Safari 13 and above, Firefox 71 and above. From the hardware perspective, we need Raspberry Pi V3 model B plus, and software interfaces we need Amazon Elastic Compute Cloud, Amazon DynamoDB, and Amazon S3. We also need wireless data transfer in order to ensure smooth connection. So our main task was to eliminate the manual meter reading system, which we have achieved in the given project. While doing so, we have also ensured the security of the system by using AES algorithms. We We have also used ECDSA in IoT devices since it has a better performance and a smaller key size compared to the less secure DSA. This system ensures correct meter reading and correct bill generation, and thus manipulation is not possible in our system. The detailed report of electricity consumption is given to the customer so that he can make the necessary changes in his usage. Thank you.
So this is how the main, once you come to the landing page of a project, this is how it looks like. So this is our user side of the project. So it has two endpoints. One is the admin endpoint and one is the user endpoint. First, let's check out the admin endpoint. Right now, as we can see that it says that the product is activated. So if we have a new customer, it first takes him to the registration page and asks him for the project key, which he gets it from our portal. On getting that, only he can use the project or the product, and that's when he has to sign up and create his own login. For login, we have given two options. One is a login, which is a normal login, which has a username and password. The other login method which we have given is login via email. We have used this method so that we can not, like, the user can not use a password on a system and try and make the system a passwordless system. So what happens is when he enters his email ID over here, he gets a link on his email address on which he can click, and he directly gets redirected to the dashboard, and his session is generated. So let's go to the login page for now, and I would just enter the login page, my credentials on the login page. And as I mentioned that the passwords stored on a system are not stored in plain text, I can show that using this method. As we can see over here, that the password stored in our system is not stored in plain text, and it is hashed 50,000 times. The iterations are 50,000 iterations. Going over to the dashboard, as we can see that this is a pretty detailed dashboard for the admin, and he can do a lot of things over here as mentioned in our use case diagram. He can add a new city or state where he wants to get new customers. He can also add a new server, a new device. Also, he can approve a new consumer, because if someone wants to register his new electricity meter, the approval comes to the admin side, and once the admin approves it, only his system is activated. For now, we have kept one active user, or active property device, and an active server. We can also see that the admin can generate his own bills. He can also, this generate bill command goes to every user, like say on 1st of every month, and it gets admin the bill generation process, which is automated in our system. He can also set the slabs. For example, right now we can see that the current slabs over here is 10 rupees cost if the number of units are between 0 to 100 for a housing meter, and for a commercial meter it's 40. And the penalty over here stands for if the bill is paid after the due date, then this penalty is added to the user. So the admin can set his custom slab which he wants. He can also add a tax and also his different amounts, like miscellaneous amounts which he wants to add. After that, he can also see that the bill which he's generating is working right or not. So in this case, we have actually given a use case. We have hard coded it that there are 500 units which are consumed. So as per our given logic, it shows that there are 12 units, 12 rupees for each unit, and that is the total cost. These are the amount of different taxes added. That is 5% of 6,000. That is 300 rupees each. And the miscellaneous amount, that is the rent for the meter, which is 100. And this gives the admin a grand total of 6,700. After this, there are also multiple other things which the admin can do. That is, we maintained system level hierarchy over here. That is, there are two types of admins which we have added over here. That is a super admin and an admin. The super admin has the complete access to the entire portal, whereas the normal admin can only do basic tasks on the device. We've maintained this so that if there's a hierarchy system in an office, that can also be maintained, and we can add more hierarchies also. Getting further, we can also update the email credentials and the other things, the usual things which are present in the project. The support query, as Santosh had mentioned, so if the user has any problems, like the client has any problems, that goes to the admin, and from here he can solve the support queries. As of now, we can see that there are no active queries for the admin. IoT server login is something. So for our IoT servers, we have not kept a direct login method over there. Like I can show it to you. Over here, if we try to log into the IoT server, there's no login credentials, or we cannot enter any credentials over here. It says that you have to log in, go to the admin dashboard, and from there try to log in. So if we try to log into our IoT server and we click over here, we will get a mail on which the login link would be there. Status shows us the current users who are present in our account. So right now we have one user who is present. We have an active server which is present, which has its own API key through which it communicates with the main server. And this is the IP address on which it's hosted right now. We can get more details about it. We also have an active device, which is for the user Steve, as we mentioned. This is how the admin portal looks like. After generation of the bill, the user also gets a mail regarding that your bill is generated. You need to pay it at the earliest. Moving ahead, now we see that we go to the user side, and a user again has two options, that is login and sign up. So if he's a first time user, he has to fill the basic form. As you can see the Aadhaar number over here, we are taking the user's Aadhaar number, and like our password is saved, we do save the Aadhaar number in a similar fashion. And after the client signs up, and if he does not have any project, he does not have access to any of the features of the product. But in this case, as I mentioned, that we have already added a um, property for the client, and which is approved by the main admin. You can see this dashboard. After on seeing this, we can see that if he sees the own properties, he can see that this is his property which is added. If he has multiple of them, all of them can be seen over here. If he goes to the view more details, he can see the statistics of how his usage has been used throughout. So in the month of January, February, March, April, how exactly his consumption has been. At the same time, if I own a property, I should be able to add a tenant. So if there's, I just need the user ID of the person who has enrolled with our system, and I can transfer this property to him. That is, give it if I'm leasing it to him. Also, there are multiple other options, like I can pay the bill, I can remove the property if I no longer have access to it, and I can see the current meter. Like this month, on this date, a meter reading was taken. So these are the, like you can see the more details over here are mentioned over here. It states that the current units cost is 11 and the current meter reading is also 11. So it gives you a detailed overview of how exactly your property, like what your meter consumptions are. Also on the rented properties, it shows that you don't have any rented property as of now. So if you have something, it will be shown over here. As we also mentioned about support queries, the support query over here is there are multiple categories of support queries. So it could be related to a meter problem, billing problem, the deactivation, if you want to stop your services and all. And you can write about it over here and send it to the admin, and a token will be generated for you on which you can track your support query. Now moving further, like I mentioned that the entire process, like we wanted to maintain security. So if we try to go to the login page of the user again, like I can just show you how we are maintaining DDoS. We are handling DDoS attacks over here. So we have tried to access this page more than 3 times. So right now, as we can see that we've got into an error, and the system is not allowing you to go to the login page. This is a mechanism which we have used because the same IP address has tried to request the system more than 5 times. And that's what usually happens in those type of attacks. There are multiple requests from different IP addresses which come in, and our code tries to analyze that which system is trying to access it and then gives access. Whereas if I want to show you the admin login, I should be able to go over there right now. So this is all about our entire project, how it works. And if you go to see the entire logs of our system, you can see that all the logs are all encrypted. Like there's no place where we are sending data in plain text, or we are maintaining any of those logs. Now over to the IoT device.
3. All right. So coming to the IoT device side, what happens here is that first of all, we need to authenticate that this device is not a malicious device and it's a part of our system. So before we log in, we uh, we send a key, we generate a key and we send it to the main server where it is authenticated, and basically ECIS is what happens. And then there's a seed which is generated on the device side and sent to the main server. And after the seed is verified at the server side, it is when the server knows that this is our device and it will send all the details to the IoT device. That is, the details about the user. I mean, which user should this device belong to, and of course, even the login details are sent to the device side, using which we can log in. Now, as you can see on the dashboard, we have two functionalities, which is registration confirm and recheck seed. So what happens when you press registration confirm is the entire cycle of this authentication gets over, and the device starts recording the data. I mean the meters, which will be sent. The meter readings, which will be sent to the main server.
I would just like to add to this, to what Adhyantini is saying, that when we click on registration confirm, the status of the device goes from false to true, which means that the device is now active and it is associated with a user.
And recheck seed, what happens when we so if there's a power cut, usually the IoT device will restart and it will reboot again. So we have just put this functionality so that it can re-authenticate itself, and the key that is the key or the meter reading, it starts again.
I would like to add one more point to this, that the recheck seed is something which you have kept for a worst case scenario, that is a manual intervention. Usually when the IoT device will come up again once the electricity is back and it's up and running, it will automatically try to connect to its parent IoT device, IoT server, and reactivate itself. That's when recheck seed happens. But in a worst case scenario, if anyone needs to troubleshoot it, we have still kept the option of recheck seed available for him.